Assalamualaikum. My name is Siti Nazira bintu Muze. I'm going to present about my mini project with my group members, which is Wepin, Reynol, Harid, Wani and Syafiqah. The Ministry of Higher Education Malaysia has put forth a proposal to construct a new office building for the university. This project is intended to provide a centralized and modern facility for the administrative and academic functions of the university. As a reputable engineering company, we are pleased to present our bid for the superstructure work and cost estimation for the substructure work of this project. The new university office building will play a crucial role in creating conducive environment for the efficient management and operation of the university. It will serve as the nerve center for decision making and coordination of various departments and faculties. Therefore, it is essential to ensure that the building is not only aesthetically pleasing but also functionally efficient. For a constructed asset-like building, a bill quantity is a document created by a cost consultant that provides project-specific measure quantities of the components shown in drawings and specification. So completing the design and developing a specification is a prerequisite for creating a bill of quantities which contains quantities that can be quantified in terms of numbers, length, area, volume, weight or time. Larger projects are typically the only ones for which bills of quantities are created. The supplier might have to measure their own amounts from design and work plans. For smaller projects, we schedule without quantities, list of instructions that give the contractor the ability to specify the main tasks and materials needed to complete the job, as well as the quantities that will be needed.
In this project, there's a few of methodology that we use. First of all, we use quantity takeoff. In civil engineering, quantity takeoff is a critical process for estimating the quantities of material that needed for construction project. The value of quantity takeoff methods are typically measured and calculated by the building construction estimator using the construction document, building plan and specification to determine the scope and cost estimate. There's a few of general methodology of quantity takeoff. There's 12 of them. So first there's a review project document. Second, organized document. Third, scale measurement. Fourth, break down the project. Fifth, identify the component. Six, take measurement. Seven, apply measurement. Eight, apply conversion factors. Ninth, consider wastage. 10, using estimate software. 11, summarize quantities. And 12, verify the cross-check. Other than that, we have a standard method of measurement, which is SMM. We use the 7th editions, SMM7. SMM, what is SMM? SMM is a set of a guideline and rules used in a construction industry for quantifying and describing building works. It provides a standardized way of measuring and describing construction work, which help in preparing bills of quantity (BOQ), and facilitating the tendering and contracting process. There's four types, which is first, there's consistency, which is it's to ensuring the measurement and description consistently applied across different projects. Second is clarity, providing clear and unambiguous description of construction work to minimize misunderstanding. Third, cost control, existing inaccurate cost estimation and control by providing a standard framework for measuring quantities. And lastly, benchmarking, allowing for benchmarking and comparison of project costs against industry standards.
So next is bill of quantity. Bill of quantity, also known as BQ, is a document prepared by a quantity surveyor or any cost consultant that provide the data of quantity of the material, labor, and also their cost in construction work. A bill of quantity makes the work run smoothly without any complexity. Sometimes a bill of quantity is used to take a reference for future project. So there are some importance of bill of quantity. So first is cost estimation. Second, scope definition. Third is contractual document. Fourth is transparent tendering process. Five is resource planning. Number six is change management. Number seven is benchmarking and analysis. Number eight, project monitoring and control. Number nine is quality control. Number 10 is financial planning. So next is scope of work. So first is superstructure design. So integrate sustainable design principle for energy efficient and environmental responsibility. Second scope of work is structure analysis. Conduct structural analysis using advanced engineering software to ensure the integrity and safety of the proposed superstructure.
Next is taking off list form. List form is started with item A, which is clearing site of undergrowth, bushes, scrub and the like, and grubbing up their roots. Next we proceed with item B, which is excavating top vegetable soil average of 150 millimeter deep, set aside, preserve for reuse within the site. Next, for item C is excavate pit for bed footing, not exceeding 2 meter depth. Next is item C, which is piling work for 300 millimeter precast RC pile type to be pre-stressed concrete pile with concrete grade D. Next is for piling work, item E, piling work of 300 millimeters precast RC pile type to be pre-stressed concrete pile in 30 meter under the ground with concrete grade D. Next is item F. For item for item F is 50 millimeters lean concrete under the pile cap. Next process is item G for formwork to height of pile cap not exceeding 1.5 meter deep. Next is item F hash 20 millimeter diameter high yield steel reinforced bar in pile cap with 2.47 kilogram per meter. And lastly, for item J, 16 millimeter diameter high yield steel reinforcement bar in pile cap with 1.58 kilogram per meter.
So I will continue for the flip side of the scale of quantities. First, we move on for the clearing undergrowth. For the clearing undergrowth, it actually is to determine the area of the site, which is the length 35.17 times 34.25 of the width, and our area of the site is equal to 1,204.57, which after rounded off is equal to 1,205 meters squared. Then for the excavation of topsoil average 150 millimeters depth site, deep depth site. Uh, Actually it's same like the clearing underground, but we need to add the foundations because that on the figure of the right side you can see that there is a space without mention any dimension of the length and the width. So we need to add the foundation. For the length of the AX to enter the AX, the foundations need to be added is one half of the P1 minus 0.15 times 2, then we'll get a total length of 35.87, and for the width, we will have a total width of 35.35 after adding the foundation, and the area of the site will be 1,268 meters square. Then for the excavate pit for flat-footing not exceeding 2 meter depth. Okay, first, we can see that the depth of the pile cap is equal to 0.9. Then we need to add the 50 millimeter link concrete and 100 millimeter stumps so that we can find the total depth and in order to find the volume. So for the 51 over at the left-hand side column is because that in the drawing it has existing 51 P1. So we need to find 51. the 1 meter over here, over the center column, is because that 1 meter is the length of the P1 and the width of the P1. So the volume of the P1 can be calculated by 1 multiplied by 1 multiplied by the total test, which is 1.05 and times 51. So we can get the total volume of P1 is equals to 53.55, and same goes to the P2, P3, P4, P5, and P7. So after calculating the volume for P1 until the P7, the total summations of these values are 167.54 and is rounded off into 168 meter cube. Then we'll go for the piling work, 300 millimeters and 300 millimeters because reinforced concrete pile type with the concrete grade 30. So at the center column here, we can see that there is a number 1, 2, 4, 5, 7. Where can we find it? Okay, you can see on the right side of the figure, there's a one node 300 times 300 precast reinforced concrete pile. You can find the number over here. This is an example of the section P1. There is given that one node. So at the P1 here, we write the 1 and times 51 is because of the number of the P1 existing in the drawing. And same goes for the P2. Because there is right 2 nodes, so the value of 2 is used, and the 15 will be the number existing of the P2 in the drawing. So the total number of P1 until the P7 will be 163 knots. Then after that, counting for the piling work will go also same as the piling work, but it's in 30 meter under the ground with a concrete grade 30, which means that the 50 for the previous one, 51 times 1 is for the piling work, but at here we also need to multiply the 30 meter under the ground. So we can see that at the P1 here, there is a 51 times 1 and times 30 and we can get the 1530 meter. Same goes to the P2 until the P7, and the total value of the P1 and until the P7 will be 4890. Then we'll go after that we'll move to the 50 mm beam concrete under the power cap. For the power cap, actually it's calculating the volume of the power cap, but the volume, the depth is equals to the 50 mm beam concrete. For the P1, 1.0 is the length and the width. The 0.05 is the beam concrete under the power cap, and the 51 same is the number axis of the P1 at the drawing there. So the volume of the total P of the 51 P1, all the 51 P1 is equal to 2.55. Same goes to the P2, P4, P5, and P6. We can calculate by using same method. However, the P3 and P7, we need to calculate the total area first because that the P3, the example over at the right hand side, the P3 is differentiate. So we need to calculate the area first. How we calculate the area? First, I assume that the base area is equal to 1.5 times 1.4 because I assume it's a rectangle. Then we need to deduct the two triangles that meets on the drawing. So the two triangles, we can know the area by the formula half over the height, which is 0.75, and the base is equal to 0.75 over tangent 64. And because there are two triangles, we need to deduct, so we need to times 2, and the total area of the P3 will be 1.83. After finding the total area, we need to times to the 0.05 of the beam complete and times to the 17, which is the number of the P3 that exists in the drawing. And the total volume of the P3 will be 1.56. Same goes for the P7. First, we assume it as a square. Then the base area of the P7 will be 2.4 times 2.4, and we need to deduct the four triangles area, which can calculate using the triangle formula. Half times the length, which is 1.13 times the height, 1.13 tangent 54, and multiply by 4 because that is 4 triangles we need to deduct. So the total area for the P7 would be 4.62, and 4.62 will multiply to 0.05 in concrete and multiply by 2, and we can found that the volume of P7 will be 0.46, and the total summation for P1 under the P7 would be 6.73 and rounded off to the 7 meter cube. Next, we will calculating for the formwork of the hull cap, which the height is not exceeding to 1.5 meter deep. So for the hull cap, for the P1, the formwork can be calculated by using the perimeter, which is because that the P1 is a square with a length of 1 meter. So the perimeter of the P1 is equal to 4 times to the height of the hull cap, which is 0.9, and times to the 51. So we can get that the P1, the value of P1 is equal to 183.60. Same goes to P2, P4, P5, and P6. We first calculate the perimeters, then multiply to the height of the pile caps and multiply to the number of each pile. Then for the P3, because P3 and P7, because the shape is special, so we need to calculate again. So for the perimeter of the P3, first I assume that it's a rectangular. So we can give I write here 1.5 times 2 plus 1.4 plus 2 times 2. Then because it is a perimeter, so we need to consider the flanked length of the P3. So the flanked length is equal to 0.75 over sine 64. But because there are two flanked lengths, so we need to times 2. And we need to minus deduct the height of the triangle and the base and the length of the triangle, which is the height is equal to 0.75 times 2 and the base is equal to 0.75 over 10^64 times 2. And for the perimeter of P3, after calculating, we can get the value of 5.22. Then the 5.22 is multiplied to the 0.9 of the height of the pile cap, and times 17, we can get 79.87. And for the P7 is same as the P3. The perimeters, the total perimeters of the P7 we get will be 8.02, then times to the height of the pile cap, which is 1.35, then multiply to 2, and we can get 31.65. So the total summation for P1 under the P7 will be 432 meters squared. Then we will continue to the higher steel reinforcement power cap. At the higher steel reinforcement bar power cap, from the drawing you can see that P1, P1, P4, P5, P6, and P7 are the same with using 20 millimeter diameter, while the P2 and P3 using a 60 millimeter. So we need to calculate it separately. So for the 20 millimeter diameter height, which is P1, P4, P5, until P7, we can calculate it by we can see for the example of P1, the length of it is equal to 1. Then we need to deduct the concrete cover on the right side and the left side, which is 0.04. So will be the length will be deduct 2 times 0.04 because of two sides, and we need to add the band because there is two band over the diagram. So we need to times 2 times the height of the hull cap, which is 0.9. But we need to deduct the concrete cover 2 times 0.04 for the top and the bottom, and also minus the empty space over there, which mentioned by 75 mm, so that the total length for the P1 will be 2.49. Since the drawing, the information didn't give the number of bars, so we need to find the number of bars by using the formula. The 0.92 over here we can find by the length of the top, which is 1 meter, minus the concrete 2 times the concrete cover 0.04, which is the 0.08. So we can get 0.92 divided by 0.1. 0.1 is stands for the H20 100C battery that's given on the right hand side of the figure. 0.1 is stands for 100 and plus 1. So we can after calculating the number of bars, which is rounded off into 10, then we need to use the number of 10 times the 51 and times the 2.47. The 2.47 is because that it is used the 20 millimeter diameter height, so it's almost the same, which is the 2.47 kilogram per meter. Then we need to multiply it the total length of the P1, which is 2.49, and for the value of P1 would be 3,136.65. Same goes to the P4, P5, P6, and the P7, and the total of P1, P4, P5 until P7 would be 4,913 and 6.66, and will be rounded off into 4,914 kilograms. Then for the 16 millimeter diameter high steel reinforcement bar in Hellcat, which is also same as 1.58 kg per meter. Actually, I explained about the P2. Actually, it is the same. The step is the same with the 20 millimeters, but the length of it will change. So for the P2, the length is 1.5. Then we need to minus the complete cover, which is 2.2 times 0.04, and add the two bands, which is 2 times 0.9, and also deduct the complete cover and the empty space 75 millimeters. And we can get the length of the P2 is equal to 2.99. The number of bars is also same. Also can be found or calculated by using the same formula, which is the 1.5 minus the complete cover divided by the 0.15 is the H20 150 C per C. So the number of bars of the P2 will be round off to be 10, and the total value for the P2 after recalculating will be 708.63. So for the P3 is also the same, and the total P2 for P3 will be 1,511.74, round off into 1,512 kg. Then for the last step is the concrete for power cap P1 until the P7. Actually, concrete for power cap is determining the volume of the power cap. For the example P1 over here, 1 meter stands for the base and stands for the width of the power cap, and 0.9 is the depth or the height of the power cap. So for the P1, the total volume of 51 P1 is equals to 45.90. Then same goes to the P2, P4, P5, and P6. The calculations are the steps of the calculations are the same. But for the P3 and the P7, we need to calculate it differently by calculating the area first. So the total area is same. The total area of the P3 is same as the in front that I mentioned before, which is 1.83 times to the height, which is 0.9, and multiply 17, we can get 28. And the P7 is also the same. The total area is equal to 4.62 times 1.35 times 2, and we can get 12.47. And the total value for P1 until the P7 would be 138.07, and the quantity will be 138 meters cubed. That's all for my part.
Now we will move to the bill of quantity. For the clearing site of undergrowth for area of 1,205 meters square with rate of 502 ringgit, cost is about Rm 605,000 in total. Excavating topsoil average of 150 mm and preserve for reuse within the site with area of 1,298 meters square and rate of 3 ringgit. Total cost is about Rm 4,167. Next, for the excavate pit for the bed footing not exceeding 2 meter depth with area of 168 meters square and rate of 14 ringgit, the total is about 2,365. Next, for the piling work for 300 millimeter square precast RC pile, pile type with quantity of 163 and market rate of 128, the total is about Rm 20,864 ringgit. Next, for the piling work, 300 millimeters square precast RC pile type, 30 meter under the ground with concrete grade 30 with 4,089 meter long and market rate of 120. The total cost is about 625,000. Next, for the 50 mm lean concrete under the pile cap, 7 meters cubed with rate of 230. The total cost is about Rm 1,610. Next, for the formwork to height of pile cap not exceeding 1.5 meter deep with area of 422 meters square and rate of Rm 20. The total cost is about 8,000 YEAR1 And next, 20mm diameter high yield steel reinforced bar with weight of 4,940 kg and rate of 303 ringgit. The total cost is about 15,724 ringgit. Next, for the 16mm diameter high yield steel reinforced bar, weight of 1,512 kg and rate of 3 ringgit, the total cost is about 5,000. Next, for the concrete pile cap P1, P2, P3, P4, P5, P6 and P7 with total area of 138 meters square and rate of 167. The total cost is about Rm 23,000. So the total of the bill quantity is about 1,312,272 ringgit.
Next, AutoCAD drawing. Okay, architecture drawing have grid line. Grid line have two: grid line horizontal and grid line vertical. Grid line horizontal is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. And grid line for vertical is A, B, C, D, E, F, G, H, I, J, K, L. Okay, in architecture drawing have dimension, detail of room, example bilik kuliah, dewan, hall, student hall, student mall, lab room, lecturer room, and detail for window, door, and detail for drain. In architecture drawing have furniture collection. Okay, next, structure drawing. Structure drawing have a little bit same for architecture drawing. Example is dimension, grid line, horizontal and vertical. And in structure drawing have ground beam. Ground beam size is 400 and 1650. Next, electrical drawing. Electrical drawing have same of architecture drawing and structure drawing. Okay, example is grid line, horizontal and vertical, dimension, and in detail of electrical. In electrical drawing have structure of electrical. Electrical drawing have symbol, ceiling fan, fan switch or other switch, 3-pin plug, MCB, chandelier light, down light, air conditioner, wall light, fluorescent light, and 1 ounce and fluorescent light 5 shot. In drawing have ceiling fan have 2, fan switch or other switch have 16 seats, 3-pin plug have 125, MCB have 1, chandelier light have 10, downlight have 54, aircon have 51, wall light have 0, fluorescent light 1 ounce have 23, and fluorescent light 5 shot have 16. In electrical drawing have detail of electrical and structure of electrical.
For conclusion, to comprehend the project budget and scope overall, quantity takers are required. A realistic picture of what is required to accomplish a project's ultimate goal can be gained by using the appropriate technology. Software programs like PROS offer precise accuracy and some of the best take-off service available. Years of experience allow cost estimators to take advantage of new technologies and obtain more precise data. Digital take-cost model greatly reduces the time required for cost estimation. Additionally, it considerably raises the likelihood of winning a bid, rework and speed bumps in the building process can be avoided. The construction of a new office building for the Ministry of Higher Education Malaysia is a complex project that requires thorough planning and efficient execution. Our department has carefully analysed the project and provided a detailed report on the engineering aspect of the construction process. With proper management and implementation of the necessary measures, We are confident in our ability to successfully undertake the substructure work within the estimated cost. We look forward to the opportunity to work on this project and contributed to the development of the education sector in Malaysia. Thank you.